All right, hello again. I'm now resuming talking about WebAssembly stuff, and I hope this isn't too terribly boring for you. So, following my nice little function prototype here, you've got a couple of local variable definitions. You can very easily understand what's going on here if you're familiar with programming languages in general. This is just saying that where I use $address, that's referring to this 32-bit integer which I've stored somewhere. Um, and obviously it's down to the, technically it's down to the machine to deal with that. You can think of it as down to the compiler, but I believe the compiler actually emits a version of the code itself as close as it possibly can. So look how beautifully complicated this is. So and again, this is the complexity that you can get with dealing with stacks, because each of these things takes a very precise number of arguments, and if the stack isn't exactly the right size, everything goes a little bit crazy. So in fact, we've got to start on the right here, which would be on the furthest to the left of the stack. So this is this simply returns, or rather, this puts onto the stack a value which is the value of this global. So from elsewhere in the file, it knows what the size is, and it will just put it in there. And this does exactly the same, but with a global value. And here we have a multiplication. So I've got to be a little bit careful if I'm looking at exactly how long it is. I believe that's the correct length. So this is simply multiplying two values which are both 32-bit integers. Again, this is what I was talking about previously about dealing with different sizes. It's generally easier if you can deal with the same size things, even if some of them are clamped to smaller ranges. So this multiplication, it consumes two values, it emits one, and then we've got something else which is using it, and that's this i32.add, which runs up to there, which again is just adding two numbers together in the 32-bit integer space, and one of them is $x, and the other one is the value of that address, and then going all the way back, you can see that this is setting another local value, but in fact, actually, it's setting a local value that we've already set. So this is a reassignment to address. Well, okay, sorry, we haven't already set it. We have already defined it. Now we're setting it for the first time. So this is basically equivalent to saying address equals x plus y multiplied by $node width. That's what's going on here. It's very, very verbose. But if you look at the individual components, it's not that complicated. It's just a little bit hard to find out what exactly there is to call. And that's a topic that I will perhaps cover at a later stage, because I did have to dig into it a bit. But in fact, what I did was look at the spec. So the specification for WebAssembly does cover everything, but it's a little bit cryptic. So it takes a bit of time to work out how to get around that. So here we've got a slightly less usual function that's being called. SHRU is a right shift unsigned, which is distinct from a right shift that's signed because it doesn't take the leftmost bit as being a signed bit. And if it did take the leftmost bit as being a signed bit, that would mean it would leave it where it is. So mostly these values, I think I said earlier that these are unsigned integers. In fact, actually, they're just integers. They're just numbers. And I suppose actually, in some sense, they could be non-integers, but floating point values are actually dealt with in a very different way. So yes, these are actually integers which don't care about whether they're signed or not. So if you're doing an add, it doesn't matter. this function, and it's the same in underlying assembly programs. If you're doing an add, the way you do that with signed values is exactly the same as the way you do that with unsigned values, which is why if you ever look at the binary expression of a signed negative value, it looks very strange, but it just looks very strange so that if you add that to a positive number, you still get the expected outcome, and you can just do that. There's no complexity to it. So, yes, this is doing a shift right, which is equivalent to division by 2, and it's asserting essentially that this value isn't signed. Shouldn't try to keep the sign bit where it is, because if you do, you'll create a mess. And this is actually shifting the value that is in $address, this value that I have just set, by 1. So it's dividing by 2. To be honest, I think probably I should have just written a divide by 2 here. It would probably have made more sense. It might be technically one instruction more, but actually no, it wouldn't be one instruction more. It would be the same number of instructions, because I would be saying i32.const 2. So a shift right is technically slightly easier for the CPU to do, because it doesn't need to work out what the other number is. It doesn't need to do anything special. So normally a division, I believe a division in so I believe a division would be done using shift right, but it would have to work out what it's got first. So it's basically more work for it to do that. Right. So this is the last command that's in here, and obviously this is the one that that returns the actual final value. So this is doing load 8u. I don't recall what that does. I think it probably copies into memory. Actually, no, it can't copy into memory, because if it did, it would have to have a memory offset. Maybe it does. Okay, I'm afraid I don't have an answer for this, but you can see the maths that it's doing here. This is getting a memory address, and then it's putting that into. Oh, okay, yeah. No, I do have an answer, but yeah, okay, I have an answer, but I don't know why I have it, which is very, very strange, because this should be addressing the memory, but I don't think it is. So yes, that's a weirdness. I don't have an answer for that. All right, so I'm actually just going to go through the rest of this file and just look for things that are kind of less useful structures, hopefully ones that I can actually give answers about, rather than this one, which I would literally have to look up to properly understand. Although I do understand what the words load and the number 8 mean, although I don't know whether it's after 8 bits or 8 bytes. But yes, I'll just go over the rest of the interesting stuff that's in here. Table 0 anyfunc. That was something that I added very early on. That was based on a recipe that I'd seen for doing WebAssembly. As it turned out, it wasn't something that was actually providing me with any benefit, so it's commented out now. If it turns out that I do have a use for it, I will come back to it, but I don't really know off the top of my head what that does. So we do have something slightly more interesting happening here. So first of all, we do have a call, which I did mention earlier. It's just open bracket, or not necessarily open bracket, but this will make your life easier, so do it. Open bracket call, symbol name, then argument, or argument, however many there are. You just do all of those. Right, so This is look at this. Look at this. This is actually using the stack for once. So you can see this doesn't have any brackets around it, and that's because it is shoving something onto the stack and then it's just letting it sit there. So that's why this looks a little bit weird. Technically, this could use brackets after it, but I believe that there's a reason why I did it this way. I think this actually takes 1 to 2 arguments, and I've deliberately done this because I want to only pass 1, because there won't be anything on the stack. So yes, this is simply a branch. So if overwrite is true, it does this, which is nothing. And if overwrite is not true, you go into this else thing. So here you can see this actually, so this is a block that runs to end, I believe. So just a block of things, but here we actually again have a case where I'm populating a value to shove into if, so that if can do its branching work. And that is the value that's produced by this lot. So this is what one of the less common cases where the brackets at a top level command are actually shoving something onto the stack. So you can see that this didn't have brackets around it, but that's because it didn't need any for passing arguments. It could have had them, I believe. But this one actually does need it because it's doing a whole bunch of stuff. So this is starting a block, and it's defining what its return value is, because it does have a return value, and then it's calling an if, and there you go. This is what I was talking about with having multiple arguments. So the if function does have a return value, which is applicable if the if statement will still have something on the stack at the end of the block. So you have to actually give it a declaration to say this is going to have one thing on the end of the block. This is what the type will be, and then you are taking the test, which is bottom here. So if bottom is true, you go into the then block, or I mean, perhaps if this red is actually true, you don't go into the then block. Perhaps something else happens. That's to be verified. And obviously, if it's not, then you'll skip over and then go into this else block. My suspicion with the fact that then is in red there, and yes, it's in red wherever I have it, my suspicion is that may have been deprecated, and it might be preferred that you just use block now, which might make a little bit more sense. So, following the if statement, so immediately following it, this is obviously the branch that you go into if everything is true. I would expect that it's just a single line, or rather, more specifically, it's a single stack entry producing entity, which is why these things are bracketed here. So this is just fetching the value of current, fetching the value 15, and ANDing them. This again could be bracketed. This is actually, at the moment, much more cryptic than it really needs to be, but I'm not going to change it right now because I need to actually set up to recompile these things. And I will need to dig into specifically what the recompile command is before I can actually do that. But it's likely that the better output, the better way of expressing this will be with brackets around it. So normally it would be i32.and in brackets itself, space, this in brackets, space, that in brackets, to have the correct value. So this is actually just taking the bottom 4 bits of the value $current. And this one as you might be able to guess, is taking the top 4 bits. So this is simply shifting the value of $current right 4 bits. I didn't actually do anything specific to emphasize that $current is actually an 8-bit value, but byteat clearly is intended to do that. So the value emitted by byteat won't be one where shifting right 4 will produce a number which is over 4 bits. So all of that, which is to say actually this, so this value here, so the top 4 bits or the bottom 4 bits of $current goes into if. And with that value, if that is true, which is to say if it's non-zero, it will do this 0 return. And this should be very familiar to you if you've if you just generally done programming. This will actually return from the function, and the value it will return with is the value which is on the top of the stack when the return is called, which, because I've done it with brackets, is the value that's to the right. We can have a whole conversation about whether these are actually brackets. A lot of people can disagree about what exactly brackets are. I consider these brackets, some people consider these parentheses, round brackets maybe. I'm just going to call them brackets. If there's a curly one, I call it a curly. If there's a square one, I call it a square. So that's what I'm going on about, if that's at all confusing to you. Okay, so this is the same kind of setup where I've stuffed one thing in the stack and then popped it out. So you might notice that this doesn't have an explicit result, which means that if it reaches the end of the control flow of the if statement with a result on the stack, or rather if the compilation would produce code which could do that, it's invalid. You've got it wrong. That's the guarantee essentially that there is nothing on the stack when I'm in this position. Although if the if had been completely bracketed, I believe that wouldn't be the case. So these are all things that we've seen before. I mean, we haven't technically seen or and, but those are just the bitwise functions that you would be familiar with. There wouldn't be a sensible Boolean or and that you could do, because if you have a value which is false, that value will be literal 0. So that would be the same in Boolean or bitwise and an or. So you don't worry about it as far as this is concerned. Potentially there, if you're dealing with actual instruction sets, you might have a way of specifically testing if a particular bit is set, which may be slightly easier for the CPU to do, but realistically, doing bitwise operations on numbers is very, very easy for the CPU to do. It doesn't care. It can just do it. So let's have a further look down here. So I note that this actually doesn't do anything very special with the if statement, but this is actually compiled a little bit differently when you have it written like this. So you might notice the presence of the word end here. That's actually needed if you are not doing it in the bracketed form. And I believe the compiler will correctly understand that the else is attached to the if, regardless of the fact that it's not actually structured in the same way if it's written out without any brackets at all. This, of course, is a shift left, where you don't need to say if it's signed or unsigned, and I guess that makes sense because if you're doing a shift left and it is a value which is signed, it doesn't really have a proper definition. I guess you probably just strip the sign bit off afterwards if you didn't want it. And then we've just got call, and this here is just putting a value onto the stack to return it. So this could equivalently be another one of these explicit return statements, but I guess I was feeling lazy at the time, so I just wrote something to put something onto the stack. Probably this is one of the earlier functions that I added, which is why it looks a little bit more differently structured to everything else. As you can see, this actually just returns a true or false value, in essence. Although this is returning 32-bit integers, it's still just true or false. It's just a 1-bit value. Okay, so down here we've got much more kind of nicely structured values. Probably I should have been doing this more with longer lines like this line here. I don't know why I didn't do it here. Obviously, the compiler doesn't care about specifically what the white space is. It cares that there is some white space sometimes, but for this purpose, it doesn't care what it is. So it can be horizontal white space, which makes life a little bit easier because you can see here what's going on. Yes, and these are actually so these are Boolean tests. So greater than or equal to signed, which I believe is actually, again, I believe this is in the same order that you have it when it's bracketed like this. So this is $x greater than or equal to node width. So here we've actually got, hey, no negatives. Here we've got a what is ultimately a number which is 1 or 0 at the end of this, because we've got a bunch of ors, we've got a bunch of tests. All of the tests will return 1 or 0, I believe, and that means that you just end up with 1 or 0 here. Potentially, you could have one of these kinds of tests which doesn't strictly return 1 or 0, but for this purpose, it doesn't matter. So you could have, so for example, you could have an EQ test, a quality test. There probably is one somewhere about, but that could internally be implemented with subtraction, which would still have the, sorry, no, I guess a not equal test. So that could be done with subtraction, which would mean that you have 0 or non-zero as your result, but it still has the same outcome in that when it runs into if, a true value will still be true. Okay, let's see if there's anything else exciting going on here. Apart from my nice comments that things are unsigned. Of course, we are kind of out in the Wild West here, where nothing's really all that strongly defined, so we actually need to leave little hints around to say what's going on here, because otherwise, what would there be? You've got to love this comment. So this is, it's a good idea to document your code, because it's not going to be very clear from just looking at it what's actually going on. So put those double semicolons in, explain what you're doing. It's going to make your own life much easier. Right, okay, and here we have an instruction that I don't quite know how it works, but given what I saw with the load 8u earlier, I think this must be implicitly operating on $mem. I don't really remember, but I believe that must be the case. So here, this is sticking a value into memory. It's a 64-bit value, and you can see it's doing all of the work to get everything into 64 bits. Although, of course, the actual underlying values are not 64 bits, they're 32 bits. It's just slightly easier in this case to store a single 64-bit value rather than two 32-bit ones. And you can see that's what this is doing. So this is saying that there is an unsigned 32-bit number, and please just shove that into 64-bit storage, which is basically just allocating an extra 32 bits at the beginning. Technically, this would be a little bit different if the value was signed, because you would actually allocate 32 bits at the beginning, then you would take the first bit from the inner value, and you would have to 0 it and take whatever the previous value was and shove it on the first bit of the 64-bit value. But all of this, as you can see, it's shifting at left 32 bits and then adding this value, which all that does is just produce a 64-bit value, which is composed of the two respective 32-bit values. All right, and we've got a loop. You see that I'm kind of quite proud of myself for having gone through and actually done a few of the different things here. So loop is just a generic loop construct. So this will just loop until the end of time. It just accepts a series of instructions inside it. It doesn't really matter how many there are. But you can see this little thing here, brf. So this tests the value that is on the right. And I believe that it just tests it if that is true and breaks 0 levels, which is to say 1 level. I would have to double check that, and don't take my word for it. Look it up. Look up what brf does. But yes, I believe that's what's going on here. So in any case, this is a break clause. This is saying that's when you finish. So this is in essence a do-while loop, if you're familiar with do-while loops. So one where it tests the condition at the very end. Okay, and we've got just look at all these loops. Look at all these lovely loops. Obviously, this code is here because it does a lot of work in a long sequence. So it makes sense for it to have loops. That's the thing that you should absolutely expect to be the case. But obviously for some functions, you still have non-looping functions, of course. But if you don't have loops in your topmost functions or in your critical functions, you kind of got to ask what you're actually trying to do there, because really the compiler will take care of you for things which aren't complicated loops. So we got some i32 stores here, which we've now established the operation of. That they must stick things into the memory that I've referred to previously. And yes, that's it. That's everything that I've got in here. So that's short of 30 minutes, but I think I've talked for quite a long time here, and I'm quite pleased about that. So that's I guess an introduction to an actually used WebAssembly file. So you can see that none of it's all that complicated, and if you've seen one that's working, you can make it work. That's the main thing. I mean, as with so many programming languages, if you have a working example, then it's very easy to work from that, as opposed from when you're writing it from scratch. So you start writing open bracket func agnode, you don't really know what's going to come next. You're just in complete confusion. So yes, hopefully this has been helpful to you if you actually are inclined to do that. So I will come back and give some proper answers about what the less obvious functions are actually doing and whether $mem is actually in use, which I'm sure it is, and I'll also go into how you compile it. But that's a very simple single command line. Probably the whole discussion won't take more than 10 minutes, I guess. Okay, thank you.